Good morning or good afternoon, friends. We are going to do Wednesday's DMR together. We are going to start with number 1. Number 1 says, what is the median for the set of numbers below? If you remember our Hey Diddle Diddle poem, the median is the number in the middle. Now, again, in order to find the middle of our data set, what do we have to do? If you said we needed to put the numbers in order from least to greatest, then you are correct. So let's do that together. I see 2 8s. Okay. Then I see a 12 and a 14. 17 and a 19. And then a 20. Okay. So now that my numbers are in order from least to greatest, I can accurately find the median or the middle. What I'm going to do is I'm going to cross out the greatest number and the smallest number in the data set, and then I'm going to approach the middle. And then I should find that one number is in the middle, and today it is 14. So that was an easy one. There was only one digit in the middle. All right, let's move on to number 2. Number 2 says the space shuttle is scheduled to take off at 10:32 p.m. on Monday. They told the astronauts that they needed to be on board 14 hours and 23 minutes before that takeoff time. What time will the astronauts need to get on board? So this is an elapsed time question. I am expecting you to set up your number line. Okay, have your number line out like me. It tells us the takeoff time and that they need to be on board before that takeoff time. So that means I'm going to put the takeoff time at the end of my number line. I know that that's when the shuttle is launching, and then the astronauts need to be on board much earlier than that time so that they can get prepared. And in the problem, it says they need to be there 14 hours and 23 minutes before. So I'm just going to write the elapsed time here. This tells me that I'm going to go find our start time using the elapsed time. I am going to make a really big first jump, and then I'm going to explain why I made that jump. So I am going to take 14 hours, and I'm going to jump 12 of those 14 hours, which is going to leave me with 2. So I'm going to put 12 hours in here. I know that there are 24 hours in a day. So I'm going to take half of that, which is 12. If I am at 10:32 p.m. and I go back a half of a day or 12 hours, then I end up at the same time. It's just the morning. I want you to think about what I did there. Okay. So that is a comfortable jump for me. Chunking a half a day, 12 hours will get you the same time, just either in the morning or in the afternoon, depending on what time you're jumping. And then I can comfortably do the 2 hours left over. So 10:32, take away 2 hours, 10, 9, 8, 32 in the morning. And then we are done with our hours. We're going to address the 23 minutes. Okay, I'm at 32. So I'm going to chunk 23 into 10 minutes. So instead of 8:32, it'll be 8:22. Okay. So that'll leave me with 13. Then I'm going to chunk 13. I'm going to chunk out 10 minutes again. So 8:22, take away 10 minutes is going to be 8:12 a.m. And then that leaves me with 3 more minutes left to jump. So I'm going to jump back 2 minutes, which is going to get me at 8:10 a.m. And then I'm going to jump back that last minute. So that means I will have no more minutes left. So 8:10 take away the last minute is going to put me at 8:09 a.m. So the astronauts need to be on board at 8:09 a.m. I'm trying to expand my camera so that you can see what I did here. Right? 8:09 a.m. is when they need to be on board. All right, number 3. Pete purchased 45 bags of peanuts. Each bag contained 133 peanuts. He then shared the peanuts with 10 of his friends. How many peanuts did each of them get? So, to me, this is a 2-step problem. The first thing I need to figure out is that if he's sharing peanuts, how many peanuts are there in all? Now, in order to do this, I know that there are 45 bags and that there are 133 peanuts in each. So I can use multiplication. 133 peanuts in 45 bags should give me a total of peanuts all together. Now, since this is a word problem, I'm going to do my math on the calculator. Don't mind Miss Conley's cat. Okay, there she is. Hey, kitty. 133 bags with 45 bags, and 133 peanuts in each gives me 5,985 peanuts all together. Okay. And then I know there's a second step because it says that Pete is going to share the peanuts with 10 of his friends. If I'm sharing something, what operation is that? If you said division, you are right. Sharing, splitting, that means we're going to divide up the peanuts with 10 of his friends. All right. When you divide 5,985 by 10, I typed it into my calculator and I got this answer, 598 and a half. Okay. Now let's look at the choices for a second. I want you to notice this amount, the total amount of peanuts, is an answer choice. But I know that's not right because that's a total amount. That is not a shared amount of peanuts between him and his friends. Okay. So I want us to go back to the answer that I got when I divided it with 10 of his friends. So if I have, I'm going to clear this out. 5,985 peanuts, and I divide it by 10, I get this amount. Now, I don't see 598.5 here, and I am thinking that if you are sharing peanuts, that maybe you can't get a half of a peanut. So I'm going to assume that they will just end up with 598 peanuts a piece, and that there will be some leftovers. That's my thinking about this problem. So I hope that your thinking matched my thinking here. All right, let's move over to number 4. Number 4 is not a word problem, so we are not going to use a calculator to solve this. Okay, it's a multiplication problem, and it has 2 decimals. Okay, so it has 34 and 3/10 times 4 and 8/10. Now I'm lining up the digits, not the decimal point. So if I have a 3-digit number and a 2-digit number, let's say you had 343 times 48, and imagine there were no decimals there, you would set it up like this. There just so happens to be decimals here, and it just so happens that when I line up my digits, the decimal point does line up, but that's not always the case, okay? Now, I've kind of taught you the strategy where you can bump out the decimal, keep track of it on the side, and then just multiply like a traditional multiplication problem. So let's just do it that way. So now that the decimal's out, I saved the decimal point from this number and the decimal point from here, so I know at the end I'll need 2 decimal places in my answer. Okay, and then we're just going to multiply like we traditionally do. So 8 times 3. 8 times 3 is 24. So the 4 is going to go here, plus 2 here. Now then we're going to do 8 times 4. So 8 times 4 is 32, plus 2 more. Don't forget that at the top. That gives us 34. So the 4 is going to go here, and the plus 3 is going to go up top. And 8 times 3. Well, we already found that 8 times 3 is 24. Then we're going to add 3 more, which gives us 27. Excuse again my cat in the background. So this should be what your first row looks like when you're using your multiplication by 8. Okay, now that we're done with the 8, we're going to cross off the 8 and we're going to hold our ones place with a 0. 0 is our placeholder. And then we're going to continue that same multiplication strategy, except we're going to use 4 now. So I know this looks a little bit messy. I'm just trying to organize it so you can see. Now we're going to do 4 times 3. Okay, 4 times 3 is 12, so I'm going to put my 2 here and then my plus 1 here. And I just scratched off the carrying that I did when I was using the 8, so I didn't get confused. Now I'm going to do 4 times 4, which is 16. Then I'm going to add 1 more, which is 17. Okay. And then my last step is 4 times 3, which is 12, and then 1 more, which is 13. All right, so I've got all my pieces here. Now all I need to do is to add here. 0 and 4 is 4. 4 and 2 is 6. 7 and 7 is 14. 2 and 1 is 3, plus 3 more is 6, and then my 1. Now, this is the most important part, is that you were actually multiplying with decimals, not whole numbers. So if you were multiplying with decimals, and let's say you bumped them out to make your multiplication easier for you, you have to remember to put them back in. So I have 2 places that I need to put my decimal back in with. So here's 1, 2. And then I'm going to put the decimal back in appropriately. So the answer is 164 and 64 hundredths. Now, I want to show you this. I didn't show you this in the last DMR where we multiplied. I think it was on Monday. If you use the strategy of bumping the decimal out, then if you like the box strategy, you could use your multiplication box strategy like this. Kitty. I'm going to show you what it would look like. So we bumped the decimal out here and we had 343 times 48. You could set up your box like this. 343 times 48. And do the box method that you guys enjoy. Let me just show you really quick. 4 times 3 is 12, plus 3 zeros. 4 times 4 is 16, and 2 zeros. 4 times 3 is 12, and 1 zero. 8 times 3 is 24, and 2 zeros. 8 times 4 is 32, and 1 zero. And 8 times 3 is 24. Sorry, my cat is so vocal today. So you could bump your decimal out like we did, then set your box up if you like the box method to multiplying, and then you would add all your pieces up. You would get the answer that I got, and then you would put your 2 decimal places back in. So there's a couple of different strategies that you can use, whatever you are more comfortable with. I will say that if you're doing math with your parents at home, we are used to a traditional model of using multiplication. You have learned in 4th grade and 5th grade some other multiplication strategies, but don't give your parents a hard time if they're showing you this way, because to me, this way will become what you will probably use in your everyday life as you get older. This is just a different strategy that we use in 5th grade. Good number sense here. A good understanding of place value, but this to me is a little bit more efficient. Okay, so let's do the last problem. We are finding a difference between 9 3/5 and 3 2/3. Again, this is not a word problem. We're not using a calculator, and difference should signal to mean what in your brain? Subtraction, I hope you said. So we are going to set up a subtraction problem with our two fractions. And we are going to write our fractions vertically. What I mean by vertically, meaning one on top of the other so we can have all this space as workspace. Now, again, you know I'm going to ask you, do you have a common denominator so that you can add 3/5 and 2/3? You do not. 5 and 3 are not the same. So we need to make a common denominator using the least common multiple. So we're going to list our multiples, find the smallest one that they have in common. So I'm moving a little bit faster today. Hopefully you'll be able to keep up. So 5, 10, 15, 20, 3, 6, 9, 12, 15. I'm stopping there because I see a common multiple. That common multiple is 15. So that means I need to change both of my fractions to have that common denominator of 15. So 5 times 1, 2, 3 is 15. Don't forget to do the numerator and change the numerator along with your denominator. 3 times 1, 2, 3, 4, 5 is 15. Again, don't forget to change the numerator. So 3 times 3 is 9, and 5 times 3 is 15. 2 times 5 is 10, and 3 times 5 is 15. Remember, our whole number is just hanging out over here. We didn't change our whole numbers. And then it looks like I'm ready to subtract because now I have 9 and 9/15 and 3 and 10/15. Okay. Miss Connolly is actually going to get a new piece of paper because I'm going to need some workspace to show you this problem. Okay. This is what we found after we have our common denominator. So make sure you have this work. Make sure you have some space because we are going to use that regrouping strategy. So I want to model something for you up top. Oh, let me think, sorry. Let's say we have 98 minus 79. Okay, let's look at this whole number problem for a second. So the number on top has 98 and we're trying to take 79. So the first thing you might ask yourself is, can I take 9 from 8? And you would say, no, I don't have enough. So you would borrow a group of 10 and 8 would become 18. And then you can subtract 9 from 18. Okay, do you see what we did there? I want us to look at that same strategy. Don't let it frighten you that you have fractions here. Okay, you might be asking yourself, can I take 10 from 9? And you can't. Okay, even if it's a fraction, you can't do it. So we're going to use that regrouping strategy where we borrow a whole from 9 and 9 becomes 8. We are going to rewrite that whole that we just borrowed as a fraction. So if my denominator is 15, I'm going to write the fraction as 15 over 15 because that represents a whole. Now I'm going to combine what was here and the whole I just borrowed. So 9 15ths and 15 15ths. Okay, you're going to add 15 and 9. You're going to get 24 15ths. Okay, I want you to just look at that strategy. Okay, borrowing a whole, adding the whole to the piece of fraction that you have here. And the reason why we're doing this is because we need a fraction big enough to take 10 away. Okay, so now that I've done that, I can take 10 away from 24. So 24 take away 10 is 14 15ths. Okay, denominator stays the same all the way through. And then 8 take away 3 is 5. Okay, we're going to do our simplifying check. I hope you can see my work as I'm going through the simplifying check. So we have 14 15ths. One of the strategies we asked ourselves is the numerator 1 away from the denominator? 14 is 1 away from 15, so it's simplified. You guys are getting so lucky with these fraction problems. They're already simplified for you. Okay? And this is our last problem. So the difference between 9 and 3/5 And 3 2/3 should be 5 14/15. Fantastic work today. I hope you guys were able to keep up. I know I was moving a little bit faster today. I am so excited that you guys are doing work right along with me. I will tell you that this is the last video until Monday. Monday, I will finish off Thursday for you. And then we will start our DMR number 28 next Tuesday. So thanks for staying patient with me while our days are a little jumbled. I am missing you, and I hope that you are safe and healthy and staying curious through all of this. Love you lots.